NASA has found signs that the moon may have caves and systems of tunnels underground, and future missions could use them to build lunar bases. The moon is constantly bombarded by high-energy cosmic radiation. This radiation is terribly dangerous to people. It can damage DNA and lead to fatal diseases. Besides, our natural satellite has almost no atmosphere, and with no protection, space rocks hit its surface non-stop. The temperatures on the moon shift from extreme heat to extreme cold, from 250 degrees Fahrenheit in the daytime to negative 208 degrees Fahrenheit at night. If we found underground shelters, they could block radiation, protect people from micrometeorites, and keep temperatures much more stable. And there's a chance of this happening. Scientists have spotted more than 100 bizarre craters on the lunar surface, and about 16 of them look like they could go down into mysterious empty spaces below, probably to natural caves or tunnels hidden under the surface. Those round holes have steep sides and look different from normal craters. Most craters reflect sunlight in a regular way, but these ones stay dark even in strong light. This means there could be edges, deep cracks, and even openings that lead down into underground spaces. Scientists found the unusual craters by studying 15 years of images from the Lunar Reconnaissance Orbiter. The orbiter's camera can capture the finest surface features, revealing hidden shapes that are hard to see at first glance. Some of the most interesting areas include Mare Tranquillitatis, where the Apollo 11 mission landed, and Mare Ingenii. It also shows signs of underground structures. These old volcanic regions may have lava tubes, natural underground tunnels that form when flowing lava creates a hard outer layer. Researchers have tested a simple but powerful method to find hidden underground caves. A team, including NASA scientists, ran tests in Arizona and California, in areas that look like the rough terrain astronauts may explore in the future. They used a method similar to a CT scan. They struck a metal plate on the ground with a 10-pound sledgehammer, which sent vibrations into the ground. Those waves traveled through the soil and bounced back from hidden structures below the surface. This allows scientists to detect what was underground. The team repeated the test again and again over areas where they knew for sure old lava tunnels existed. Each time, the results confirmed the same thing. This method can detect hidden voids and buried caves deep beneath solid rock. It means that one day we could use it to explore the insides of the moon. Way out by Saturn, there's an icy moon called Enceladus. And it's literally spitting out ice into space. And that ice contains the stuff life's made of. Oh, and there's a whole ocean hiding under the ice. And who knows what's living in it. Enceladus is only about 300 miles across. It could literally fit inside the state of Colorado. But even though it's super small, it's got liquid water, energy from hydrothermal vents, and a bunch of chemicals that could actually support life. In other words, it's one of the best spots in the solar system where life could exist. Now, rewind about 20 years. NASA's Cassini spacecraft flew by Saturn and noticed something strange. Enceladus was shooting out little jets of icy particles from cracks near its south pole. Later, scientists realized those jets were coming from a giant underground ocean beneath the moon's surface. When they analyzed the frozen grains from those plumes, they found almost all the elements needed for life: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Only sulfur was missing. The only problem was, most of those samples came from Saturn's E-ring, a huge ring made of dust and ice that surrounds the planet. And those particles had been sitting out there for decades, maybe centuries, meaning they could have been changed by space radiation. So no one could say for sure if those life ingredients really came from Enceladus itself. But now that's changed. A new study has just confirmed that fresh ice grains, the ones newly blasted out from Enceladus, contain organic molecules, including stuff like nitrogen and oxygen. Here's how scientists figured it out. In 2008, Cassini flew right through one of those icy geysers, and it literally got splattered with tiny particles. They hit the spacecraft's dust detector at insane speed, 11 miles per second. That's fast enough to separate all the molecules, so the team could see what they were really made of. Then the scientists used a technique called mass spectrometry and managed to study those fresh grains in detail. They found molecules that on Earth are part of certain chemical reactions. Those build the complex structures life needs to exist, including ones that may contain nitrogen and oxygen.
One of the researchers said that this likely proved that those complex organic molecules hadn't formed in space. They might have actually been coming straight from Enceladus's ocean. Another scientist explained that those molecules could play an important role in biological processes. All this means that Enceladus might really be habitable. But even if there's no life there, that's still a big deal. Because then we have the right to ask, wait, why isn't there life when all the right conditions are in place? The story doesn't end there. The European Space Agency is already planning a future mission to actually land on Enceladus, right at its south pole. They want to scoop up more samples and see what's really going on under all that ice. The launch is planned for sometime in the early 2040s, so in just a few decades, we might finally find out whether this tiny frozen moon is home to some bizarre life forms. But Enceladus isn't the only potentially habitable place we know about. Admittedly, the others are beyond the edge of our solar system. Like 3 possible super-Earth planets orbiting a nearby orange dwarf star. Now, super-Earth is just what scientists call planets that are bigger than Earth but smaller than the icy giants like Uranus and Neptune. Scientists from the University of Exeter found that those exoplanets were orbiting their parent star, HD 48498, which sits about 55 light-years away from Earth. That's practically our cosmic neighborhood. Each of these planets takes a different amount of time to go around its star. One needs 7 Earth days, another 38 days, and the last one 151 days. And the coolest thing is that the outermost planet might actually be hanging out in the star's habitable zone. That's the sweet spot where it's not too hot and not too cold for liquid water to exist. It means the planet's surface could be comfortable enough for water to exist without boiling or freezing. This makes it a great candidate for life as we know it. Over 10 years, the team collected nearly 190 super precise measurements using cutting-edge equipment that looks at the light coming from stars. By checking whether the star's light is slightly shifting toward us, this is called blue shift, or away from us, that's red shift, they can figure out if a planet is tugging on it. The host star itself is an orange dwarf, something like our Sun's smaller and calmer cousin. It's similar to the Sun in many ways, but as an orange dwarf, it gives off less radiation than our yellow dwarf star does. The coolest part is that this is one of the closest planetary systems we've ever found that hosts a super-Earth in the habitable zone around a Sun-like star. Now, super-Earths aren't exactly rare. Scientists have found over 6,000 exoplanets since the first one orbiting a Sun-like star was confirmed in 1995. To spot such distant worlds, astronomers use all sorts of tools like NASA's Kepler telescope, launched in 2009 to find Earth-like planets in the Milky Way. Let's sneak a peek at some of the most exciting exoplanets out there. Gliese 667 cc is only 22 light-years away, even though that's still about 129 trillion miles from us. It's about 3.8 times the mass of Earth, and zips around its red dwarf star in just 28 days. So a year there is 13 times shorter than ours. Its red dwarf star is cooler, and the planet probably sits in the habitable zone, though occasional stellar flares could give it a sunburn. Kepler 22b is way farther out at 600+ light-years. It was the first Kepler planet found in a habitable zone. It's about 2.4 times bigger than Earth, and we still don't know if it's rocky, liquid, or gaseous. Its orbit is close to Earth's, taking 290 days to circle its G-class star, smaller and colder than our Sun. Kepler-69c is a whopping 2,700 light-years away. This planet is almost 70% larger than Earth. Its orbit takes 242 days, putting it in a Venus-like spot in its system. But since its star is only 80% as luminous as our Sun, the conditions on that planet might be way friendlier than those on Venus. We discovered TOI 733b in 2023. This world is about 245 light-years away. It orbits its star super fast, taking just 4.9 Earth days. But the coolest thing is that it might be completely covered by a massive ocean. Could there be life in that ocean? Time will tell. GJ 1214b is 40 light-years away, pretty close by space terms. The planet is almost 3 times Earth's diameter and 8 times as heavy. It needs 38 hours to orbit its red dwarf star. The surface temperatures there hit 450 degrees Fahrenheit, and with all that heat and pressure, water behaves in crazy ways, like hot ice or superfluid water. By the way, that superfluidity is wild stuff when water moves like magic without friction. But don't try it on Earth. You'll just get dehydrated. Proxima Centauri b is the closest super-Earth, sitting at just 4 light-years away. It has a similar mass to Earth's, but a year there is only 11.2 days. Its star even wobbles a bit thanks to the planet's gravity. That's actually how scientists discovered it. The planet sits in the habitable zone but gets blasted by extreme UV radiation because it's super close to its star. Right now we can't even study its atmosphere. And finally, TOI 715b. This one orbits a red dwarf, which is smaller and cooler than our Sun. These tiny stars are pretty great for finding habitable worlds because planets can orbit close without frying. TOI 715b may have once had a super thick atmosphere like Neptune's, but it might now be losing it. Scientists need more research to see if it's now a watery, rocky world. In any case, some of these planets might have oceans, some might be way too hot, and some could even be our distant cosmic cousins. Either way, each discovery helps us understand the universe a little better. And who knows, maybe someday we'll even set foot on one of those super-Earths.
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the sun and from space. But even though Saturn is protected by its magnetosphere, the sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
Prepare for blast-off, because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon, Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor, literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are two possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years.
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its two host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals. And it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar. At least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now, let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby: gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pavlovsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved, without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic Anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic Anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic Anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball, but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes. Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guest said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new: a bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things: really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear: the typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet.
Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble teleos, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Teleos is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star, called a white dwarf, starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Teleos. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Teleos doesn't show any, not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Teleos might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Teleos looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Teleos is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Teleos' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Teleos be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Teleos. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be. And none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Teleos can exist, what else is out there, waiting to challenge everything we know about the universe? So, astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now, this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch, or the fawn, in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new left-bot has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT 2024 WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole left-bot thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes – small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. Lisa will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real, and they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science.
This terrifying but very much real image emerged just recently. In it, you can see something that looks like it belongs in a science fiction movie. From far above Earth, aboard the International Space Station, an astronaut captured something astonishing over Louisiana. A gigantic jet blasting upward straight into the sky. It looks as if Earth is sending a signal skyward. Can science explain this eerie phenomenon? Apparently, it can. This energy blast is called a gigantic jet, and it's one of the rarest and most powerful kinds of lightning we know about. Unlike regular lightning, which strikes down toward the ground, gigantic jets shoot up from storm clouds, and they can stretch for more than 50 miles into the sky. Sometimes they even reach the ionosphere, the layer where Earth's atmosphere starts blending into outer space. To give you an idea, space officially starts around 62 miles above sea level, and the ionosphere stretches from about 50 to 400 miles up. Shockingly, scientists have only known about gigantic jets for about 20 years, and we're still figuring out exactly how they work. One theory is that something inside the storm cloud blocks the lightning from escaping downward. So all this pent-up energy looks for another way out and ends up blasting upward into the sky. But honestly, we still don't fully understand why it happens. Gigantic jets are also extremely rare. Scientists think that they happen only around 1,000 times a year on the entire planet. And when they do happen, they carry a lot of energy. We're talking more than 50 times the power of a normal lightning bolt. The strongest gigantic jet ever recorded happened in Oklahoma in May 2018. It was intense, reaching a temperature of 8,000 degrees Fahrenheit and releasing about 60 times more energy than regular lightning. In other words, it was a huge burst of electricity flying straight into the sky. Most of the photos we have of gigantic jets come from satellites or astronauts on the International Space Station. But a few have also been captured from airplanes flying over storms. The latest jaw-dropping image was taken on November 19, 2024, by an astronaut aboard the ISS. At first, the picture wasn't released by NASA or any space agency. But one photographer, known for tracking and photographing rare lightning events, found the photo by accident. He was browsing through a NASA-run website called the Gateway to Astronaut Photography of Earth, which hosts photos taken by astronauts. There, he spotted images showing a giant lightning jet. Eventually, the photos were brought to public attention on February 26, 2025, and they've also been turned into a time-lapse video on YouTube. We still don't know exactly about the exact spot where the jet happened. Thick storm clouds covered the ground in the pictures. But based on where the ISS was flying at the time, the jet probably happened just off the coast of New Orleans. Speaking of other images of the gigantic jets, a photographer living in Puerto Rico was taking pictures of a storm moving through the area. That same storm would later grow into Hurricane Franklin. While watching the skies, he saw something truly amazing. Several massive lightning bolts shooting straight up out of the storm clouds, stopping just below the edge of space. No wonder. According to a 2022 study, gigantic jets happen most often in tropical areas, and they're more likely during fast-growing storms, like Hurricane Franklin. Gigantic jets often end with thin, red branch-like lightning tendrils. These faint red flashes are very similar to another rare type of lightning called sprites. Those sometimes look like giant glowing jellyfish in the sky. In 2023, an astronomer named Stanislav Kaniansky in Slovakia captured one of the clearest images of a sprite ever. It happened during a thunderstorm over Central Europe on August 14th, and he spotted it near his home. In the photo, you can see a huge glowing red structure with zigzag patterns stretching over 31 miles across the sky. But like all sprites, it only lasted a fraction of a second before fading away. Sprites happen when lightning sends electrical energy upward into the upper part of Earth's atmosphere, instead of just downward like regular lightning. This energy creates glowing strands of plasma, which is basically electrified gas, way up in the ionosphere. Since sprites are so fast and often hidden by thick clouds, they're very hard to photograph. But Kaniansky got lucky. The thunderstorm was about 200 miles away from him, so he had a clear view just above the tops of the storm clouds. That perfect angle helped him capture this stunning phenomenon. There are many different kinds of lightning, and some of them are not only rare but also super dangerous. Let's take ball lightning, for example. It's exactly what it sounds like, a glowing, floating ball of light that appears during thunderstorms. It's also one of the weirdest and most mysterious forms of lightning. People have seen these strange light balls, usually about the size of a grapefruit, slowly spinning or hovering just above the ground. Some even say they've seen them float through closed windows or suddenly appear indoors, then vanish after about 10 seconds. For hundreds of years, no one really knew what caused ball lightning. Scientists had no explanation, and most sightings were based on eyewitness stories. Then, in 2012, someone finally managed to capture ball lightning on camera. Since then, different ideas have come up to explain what ball lightning really is. One of the newest theories suggests that the ball is actually a tight bubble of super compressed air. This compressed air bends and spins white light in all directions, making it look like a glowing ball rolling around in the sky. And according to the researchers, ball lightning can be almost 1 billion times more intense than regular lightning that moves in a straight line. Then there are elves. They look a lot like sprites, but instead of looking like jellyfish or dancing shapes, elves appear as huge glowing rings or halos in the sky. And they're massive. An elf can spread out to be up to 185 miles wide. You can even spot them from space or through thin clouds during the day. Dark lightning is probably one of the strangest types of lightning, and most people don't even know it exists. Unlike regular lightning, it doesn't produce a bright flash. Instead, it gives off intense bursts of radiation, especially gamma rays, the most energetic form of light found in nature. Dark lightning happens when high-speed electrons slam into air molecules inside a storm cloud. This creates a burst of gamma rays. They're so strong that they can mess with satellites hundreds of miles away in space. In rare cases, when a plane flies through a thunderstorm, these flashes can hit the aircraft. Some passengers could get a quick dose of radiation, about the same as a full-body CT scan. But worry not. Scientists say these occasions are extremely rare and not a reason to be afraid of flying. And finally, there's positive lightning. You see, lightning is still kind of a mystery, even for scientists. But here's the basic idea. Inside a storm cloud, tiny pieces of ice bump into each other and build up electric charges. Some become positive, others negative. Most of the lightning we see comes from the bottom of the cloud, where there are lots of negative charges. These reach down and zap the ground. But sometimes, lightning comes from the top of the cloud, where positive charges hang out. That's called positive lightning, and it only makes up about 5 to 10% of lightning strikes. Most of the time, those positive charges just zap other parts of the cloud. But sometimes, they shoot all the way down to the ground. That's why positive lightning can strike even when the sky looks clear, because it comes from way up high in the cloud, sometimes miles away from the storm itself. The scariest part is that regular lightning can reach about 300 million volts, while the charge of positive lightning can be up to 1 billion volts. That means positive lightning is much stronger and more dangerous. The moon might be hiding trillions of dollars worth of materials beneath that dusty surface, and NASA is about to get a piece of it soon. Their new lunar drilling tech just passed its first big test, and it could open up an entirely new frontier: space mining. This isn't just a scientific milestone. This could change the US economy forever, and maybe even reshape life on Earth. That's because they found something rare in lunar soil. Something that could become essential for us in the future: helium-3. Okay, so you know helium, right? It's the gas that makes birthday balloons float. Helium-3 is not that. It's a special isotope of helium, which basically means it has the same number of protons, 2 by the way, but a different number of neutrons. That's chemistry speak for it's rare, like super rare. Here comes the sad part. Earth had helium-3 once, a lot of it actually. But during our planet's formation, a lot of it escaped into space. Turns out, it's super light, so it didn't stick around. But we can still find it here and there, mostly inside our planet. I mean, there's some of it literally trapped underground. Or even a lot, as some recent studies might suggest. But still, the problem is that extracting helium-3 is expensive, limited, and seriously difficult. So difficult, in fact, that getting it from the moon suddenly sounds like a piece of cake. To really understand why extracting helium-3 in space might be easier, we need to quickly compare Earth and the moon. So here's the sun, right? This huge ball of fire in the sky constantly shoots out tons of helium-3. When this helium-3 reaches Earth, our planet's magnetic field acts like a giant invisible shield, basically saying, "Nope, not here," and it deflects most of it away. But the moon doesn't have a friendly protective magnetic field like Earth does. So when helium-3 reaches the moon, it hits the surface directly and gets trapped in the lunar regolith. I'm talking about that loose layer of dust, soil, and rocky debris covering the moon. And there might be tons of it, literally. Some estimates put it somewhere between 1 and 3 million tons of helium-3. The best part is that almost all of it is probably sitting right in the top layer of lunar soil. So instead of heavy-duty drilling, it could be as easy as just scooping up some moon dust. That's why a lot of people think getting helium-3 from our natural satellite could actually be way easier, or maybe even cheaper, than digging deep underground here on Earth. Now, you're probably thinking, why go through all that trouble? I mean, if it doesn't work for birthday balloons, what's the big deal with helium-3? Well, for starters, it's already being used in advanced medical tech, like magnetic resonance imaging and X-ray. But here's the real game changer. Helium-3 could actually end our dependence on fossil fuels for good. This rare isotope could be used for advanced nuclear fusion reactors here on Earth. In other words, it could give us nuclear energy that's not just super efficient, but a whole lot safer too. See, most nuclear power plants today run on a process called fission. They use uranium-235, and when those atoms split, you get a ton of energy. But you also get something else: radioactive waste. And yeah, it's just as dangerous as it sounds. But helium-3 is different. It could power future reactors with a process called fusion. If you mix helium-3 with a type of hydrogen called deuterium, you get a lot of energy, but without the dangerous waste. It could be cost-efficient too. Let's say a single space shuttle cargo bay could carry about 25 tons of helium-3. That would be enough to power the entire United States for a year. And scientists believe there's enough helium-3 on the moon to power the whole world for 10,000 years. These are only estimates for now, but the future potential is so exciting that the demand for helium-3 is already skyrocketing, and so is its value. In 2024, some experts say that the helium-3 market was worth about $670 million. This year, it's expected to hit around $730 million. And 10 years from now, experts believe it could reach nearly $1.6 billion. Sorry for all the numbers, I just wanted to show you why mining the moon matters. It might actually save us from a future energy crisis by giving us almost endless, clean nuclear power. Everything sounds great so far, but there's one big challenge. Mining helium-3 on the moon is one thing. Bringing it back to Earth is a whole different story. So let's look at one possible solution. First, robots or specialized machines would drill into the lunar soil or simply scoop up moon dust to collect the helium-3. Then it gets packed into containers and launched off the moon, heading for Earth. When the containers get close to Earth, a ship called the Space Rapid Transit will pick them up in orbit. Think of it as a reusable space truck with engines that can even use air for thrust. Finally, the ship would land at an airport here on Earth. From there, the helium-3 would head straight to power plants, giving us clean, safe, and almost unlimited energy. See how challenging it sounds, right? Of course, specialists are still figuring out the best way to transport helium-3. But one thing is certain, we're getting closer and closer to building a full mining base on the moon. NASA recently tested a new drill technology called Trident. And as soon as it touched the lunar surface, it started working right away and performed perfectly. For now, its main purpose is to bring soil to the surface so scientists can study it. They want to learn more about how strong the lunar regolith is and how it reacts when drilled. That's definitely an exciting step towards extraterrestrial mining. Because it's not just helium-3, you know. There are a lot of other valuable things that can be taken from the moon. For example, there's water ice on the moon, and from that, we could extract oxygen and hydrogen. Then there could be rare and expensive metals like platinum, rhodium, and iridium. We could even mine iron, silicon, and aluminum, which would be perfect for building things directly in orbit, like future space stations or other infrastructure. Now that we know how important mining the moon could be, you're probably wondering, is any of this even allowed? I mean, who actually owns the moon? The short answer? Nobody. Even though NASA is up there doing research, that doesn't mean the United States owns the moon. Back in 1967, some nations signed the Outer Space Treaty. It basically says no one can claim ownership over our natural satellite or any other celestial body. Not an asteroid, not a planet, not even a random rock floating out there. So, if a country wants to explore the moon, sure, they can do it, but they can't plant a flag and say, "This is ours now." Here's where it gets messy. Companies. There isn't much of an agreement about what private businesses can and can't do out there. For example, a private company sets up a moon base. They land a successful spacecraft, build a small station, and even start digging. The base itself belongs to them, sure, but the land they're sitting on does not. Everyone is on the same page up to that point. The tricky part is, the treaty doesn't really spell out what happens to the materials they dig up. Nobody is totally sure if those resources would even belong to them. And if the materials are not technically the company's, can they even sell them? It's hard to say. So yeah, sorry. Even if you had the cash to build your own lunar base, you probably can't just scoop up helium-3 and bring it back as a souvenir. I mean, unless you want to risk becoming the first person ever banned from the moon.
5, 4, 3, 2, 1.
Ah, Saturn. Incredible with its majestic rings and swirling clouds. But what would it be like to dive into it? NASA's Cassini tried that, and it turned out to be a wild trip. NASA's Cassini spacecraft was a probe that spent 13 years orbiting Saturn and gathering some incredible data. One of its major goals was to help us understand how come Saturn's atmosphere is so hot. The upper atmospheres of planets are always heated, duh. They're directly under the sun. The strange thing about Saturn is that gas giants are too far from the sun to get that kind of warmth. So Cassini didn't just observe the planet from outside. On September 15, 2017, it dove deep to the journey that would become the spacecraft's grand finale. Its last moments were spent inside Saturn's upper atmosphere, sending back priceless data as it slowly disintegrated. Now, these upper layers are no joke. The planet's horrifying magnetic field hums with energy, and powerful winds whip around at thousands of miles per hour. Cassini would pass through thick layers of clouds, hazy, pale gold, and muted, reflecting the sun's faint light. And these aren't cute, fluffy Earth-like clouds made of water vapor. This is a nightmare cocktail of hydrogen and helium. The probe ventured deeper, passing through the region where Saturn's iconic rings rain material onto the planet. Cassini discovered that this rain was more intense than anyone expected, more than 22,000 pounds of material per second. That's at a rate that Saturn's rings might not last forever. The planet's own gravity could eat them away completely someday, unless the rings get a sudden update. These are all tiny grains of ice and dust, caught in the planet's gravity, falling into the atmosphere like a relentless storm. The grains, mixed with water, methane, and even chemicals like propane and butane, slowly alter Saturn's atmospheric chemistry. It mixes with the particles in the planet's upper atmosphere, making them heavier and warming Saturn up. Unfortunately, this was too much for poor little Cassini. It was designed to be tough enough for the outer layers, but it burned up before it could descend into the terrifying deeper regions. In the more intense layers of Saturn's atmosphere, winds reach extreme speeds of over 1,100 miles per hour. The pressure becomes crushing, and the deeper you go, the more overwhelming it becomes. It would feel like entering an ocean of gas, one with no clear surface, where the sky gets darker, thicker, and more hostile as you descend. And at a certain point, complete darkness. Just you and the overwhelming mass of hydrogen gas pressing in from all sides. But Cassini's sacrifice was invaluable to scientists. The key data it sent us before the grand finale allowed scientists to map Saturn's upper atmosphere more completely than ever before. Cassini tracked bright stars, like those in Orion and Canis Major, as they passed behind the planet, measuring how their starlight shifted. This helped scientists to understand how dense and hot the atmosphere was. It left us some final pictures as well, though they're not as impressive as you might think. It was a monochrome shot taken from about 394,000 miles away, showing a dark portion of Saturn's night side, softly illuminated by the reflection of its own rings. NASA also posted a picture made by their own artists of what Cassini could have seen in its last moments. And of course, it gave us the answer to the big mystery of Saturn's heat. It's because of auroras. It turns out that due to the crazy magnetic field, the planet's cloud layers are sparked up by sudden bursts of auroras at the poles. They're like the northern lights on Earth, but far more intense. The gas giant skies occasionally light up with radiant greens and blues. They're sparked by the interaction between solar winds and the charged particles from Saturn's moons. The hottest areas of Saturn were near these auroras. These light shows are powerful enough to heat the upper atmosphere, spreading warmth across the planet. Thanks to this added information, we discovered something important, not just about Saturn, but about all gas giants across our solar system and beyond. Meanwhile, the photos we have of Venus are much more dramatic. Venus is a bit closer to the Sun than Earth. It's often been called Earth's twin because of the similarities, like in size, mass, and composition. But don't be fooled. Beneath those thick clouds lies one of the most toxic environments in our solar system. Its surface is a nightmare, where temperatures soar to about 900 degrees Fahrenheit, hot enough to melt lead. The pressure on the planet is crushing as well, 92 times that of Earth's. That's like standing 3,000 feet under the ocean. We just couldn't resist taking some pictures. So, in the 1970s, scientists managed to land probes on this volcanic, unforgiving surface. And these missions were successful. They managed to send back the first photos of Venus and showed us incredible stuff. The first probe lasted only 23 minutes on the surface and then crushed down under this crazy pressure, winds, and heat. Both first and second probes captured black and white panoramas of a rocky hillside. On both, the second lens failed to eject. The horizon was flat, the ground strewn with jagged rocks, and the oppressive atmosphere pressed down like an invisible force. After lots of hurdles, we finally managed to look at colorful pictures from Venus in the 1980s. This spacecraft lasted more than 2 hours after extreme conditions. It's incredible that they managed to send us anything at all. Venus is a planet where metals melt and where the atmosphere itself eats away the spacecraft. The photos it took showed that on Venus, the skies aren't blue, but an eerie yellow due to the thick clouds of sulfuric acid. NASA also has some computer simulations of what Venus's surface could look like, but these don't really convey the horror of actually being there. Perhaps it's time we look at Venus once more. There's so much we don't know about this fiery neighbor. Finally, we also tried to enter Jupiter's atmosphere in the 90s, and that's the hardest one on the list. NASA's Galileo missions probe was designed to dive into Jupiter. It was launched in 1989 and traveled millions of miles with a small entry probe on board. This tiny hero would face one of the most intense environments we've ever encountered in space. It was finally released on July 13, 1995. At that moment, the spacecraft was still 50 million miles away from Jupiter, so just to enter the atmosphere, it had to fall for months. And it finally did fall on December 7th, plunging headfirst into Jupiter's thick, swirling atmosphere. The probe slammed into Jupiter's skies at a staggering 106,000 miles per hour. That's fast enough to cross the United States from Los Angeles to New York in 90 seconds. The intense deceleration caused the probe to experience a horrifying gravity, 228 times stronger than the Earth's. It slowed down from supersonic speeds to just 100 miles per hour in minutes. The heat generated by its entry was so extreme that the shock wave ahead of it glowed as brightly as the sun itself. The temperature soared to 28,000 degrees Fahrenheit. And all this time, somehow, the probe was collecting data every second and sending it all to us. It gave us some critical information about Jupiter's mysterious atmosphere. For example, it turned out that Jupiter's upper atmosphere was drier than expected, less water vapor and fewer organic compounds than scientists thought. The probe also measured fierce winds of up to 0.5 mile per second. And surprisingly, it didn't see that much lightning, even though we thought these are never ending on Jupiter. One of the probe's biggest surprises was the discovery that Jupiter's atmosphere contained less helium than we thought. It also revealed a horrifying radiation belt about 30,000 miles above Jupiter's clouds. It's like intense radiation encircles the planet like a cosmic shield. The poor little guy managed to survive for 58 minutes. It eventually succumbed to immense pressure. Meanwhile, the Galileo orbiter continued its mission, becoming the first spacecraft to orbit Jupiter. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star. and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth, it's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet. This catapult-like system on the Moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the Moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The Moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the Moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the Moon and barely none on our planet? Well, that's because helium-3 comes from the sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remains stable at high speeds, and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out. Ooh, that quick flash. Did you see it? That's an object smashing into the moon at unbelievable speed. And what makes it so special is that we almost never catch lunar impacts in real time. We still don't know what exactly hit it, but scientists think it might be linked to the Phaethon asteroid, one of the strangest, most mysterious objects we know of. This impact happened on December 12, 2025. Andrew Marshall Lee, a final-year PhD student, was doing a late shift at the Armagh Observatory and Planetarium in Northern Ireland. He was working with the Armagh Robotic Telescope, the newest and most advanced one there. Everything seemed normal at first. The moon was just sitting quietly on his screen. But then, around 3 in the morning, something unexpected happened. He saw a flash. That was the impact of a small object hitting the moon. The team is still trying to pin down its exact size, but they think it was no bigger than 2 inches across, which is about the size of a golf ball. And this object was moving insanely fast, at about 22 miles per second. To give you an idea, it's more than 100 times faster than a commercial jet. And yeah, I get it. When you watch the video, it's only a quick blink. It's not exactly thrilling. But the fact that Marshall Lee caught the exact moment it happened is actually super rare, and that's what makes this one such a big deal. It's the first video recording of a lunar impact flash in Ireland, and only the second one ever recorded from the United Kingdom. But just because it's rare to see that kind of event happen, that doesn't mean impacts on the moon are rare. It's actually the total opposite. We have a huge advantage on Earth, our atmosphere. It works like an invisible shield. It slows down incoming space debris, and it can even burn a lot of it up before it reaches the ground. But the moon doesn't have that kind of protection. So our poor natural satellite gets hit all the time by asteroids and meteorites. The good news is, most of what hits it is tiny, no bigger than little specks of dust. Now, if we talk about slightly bigger ones, we can look at some rough numbers. Scientists think around 100 space rocks the size of ping pong balls hit the moon every single day. That adds up to roughly 36,000 in a year. So, it's kind of strange that we don't capture these impacts more often. But the explanation is actually pretty simple. As we mentioned earlier, these space rocks are usually tiny, and if a ping pong ball already looks small here on Earth, imagine something that size flying through the huge emptiness of space. We can say it's basically invisible. That's why we usually can't spot them with a telescope. They're too faint for that. But the moment one of these little objects hits the moon at a crazy high speed, everything changes. The energy from the impact turns into heat and light. It blasts and melts a bit of the surface, and for a split second, it makes a bright flash that we can see from Earth. And there's one more problem. The moon is huge. Impacts can happen anywhere on its surface, so it's almost impossible to keep a telescope pointed at the exact spot where the next big hit will happen. So, most of the time, scientists don't catch lunar impacts with their own eyes. What usually happens is that they record the moon for hours, run all that footage through some software, and the program flags it if a flash shows up. But in Marshall Lee's case, he just happened to be looking at the screen at exactly the right moment, and he saw it happen live. Now you get how lucky he was, right? For now, the team has a pretty good idea of the space rock's size and speed, but it's still hard to say exactly what it was or where it came from. Their best guess is that it was linked to the Geminid meteor shower, which happens in December. And that actually makes sense. Lunar impacts are more likely to be spotted during big meteor showers, when the moon passes through streams of leftover space debris. So this could be one of those moments where the timing was just perfect. Now, the Geminid meteor shower is tied to one of the strangest space objects we know of, called Phaethon. It's labeled an asteroid, but it certainly doesn't behave like a normal one. You see, when Phaethon gets close to the Sun, it brightens up and even forms a tail, just like a comet. But its tail isn't made of dusty material the way comet tails usually are. According to NASA, its tail is made of sodium gas. That's why scientists are not totally sure what to call it. So, for now, Phaethon is officially listed as an asteroid, but a very weird one. Anyway, this strange object swings closer to the Sun every December, and when the heat gets intense, Phaethon starts shedding tiny bits of rock. When those little pieces dive into Earth's atmosphere, they burn up and make bright streaks across the night sky. At the peak of the Geminid shower, people can spot up to 120 meteors an hour under perfect conditions. The Geminids are usually bright and fast, and they often look a bit yellow. Of course, not all of those pieces hit Earth. Some miss us completely, and a few end up hitting the Moon instead. And that's probably what Marshall Lee saw that night. Now, even though the impact wasn't huge, flashes like this are still really useful for science. Astronomers use them to estimate how often the Moon gets hit by small space rocks. And once they know that, they can make better guesses about how many bigger asteroids are out there, the kind that could make it through Earth's atmosphere and cause real damage. And sightings like this matter for the future too, especially for space travel. Space agencies want to build bases on the Moon, and the goal is to make it a place where people can stay and work, not just visit. The Moon is our closest neighbor in space, so it's a great place to learn new things and try out new tools. It's also the perfect practice ground for bigger missions later on, like sending humans to Mars. NASA, for example, is working on something called Artemis Base Camp. The plan is a small base near the Moon's south pole, with places for astronauts to live and work, plus a rover that can travel farther from where they land. NASA also has plans for the Lunar Gateway, a small space station that would orbit the Moon and help crews and supplies move between Earth and the Moon's surface. There's also the International Lunar Research Station program. Its goal is to build a long-term research base on the Moon, starting with robotic missions that land first and prepare the area before people arrive. The program focuses on using local resources, such as ice in the Moon's soil, to produce water, oxygen, and other supplies needed for life. By staying on the Moon for longer periods, scientists hope to learn how humans can live and work far from Earth and use this experience to prepare for future missions to Mars and beyond. So, keeping an eye on these impacts and learning more about them could actually help us build a safer future beyond Earth. The more we understand how often these hits happen and how strong they are, the better we can plan and protect future lunar bases. In a way, that tiny flash on the Moon isn't just a cool moment on a screen. It's a small warning and a useful lesson for what comes next. Now picture a strange world where molten metal falls from the sky, a planet where it rains glass sideways, a place where the winds are many times the speed of sound. Even though these planets sound like stuff from a nightmare, they do exist. Would you survive on any of them? Nope. But come on, let's see why. Now, brace yourself, and I mean it literally, because WASP 127b is terrifyingly windy. On Earth, our most powerful storms produce winds around 200 miles per hour. And even Neptune, the windiest planet in our solar system, tops out at about 1,100 miles per hour. But on 127b, winds dash across the equator at a staggering 20,500 miles per hour. That's 35 times faster than a jet and faster than the speed needed to orbit the Earth. 127b orbits a star similar to our Sun, but it's super close to its parent star, only 4.3 million miles away. That's why it takes just 4.2 days to make a full orbit. The heat there is insane. Cloud tops reach 1800 degrees Fahrenheit, which is enough to melt almost, anything. And 127b is supermassive. Well, kind of. It's a gas giant with a diameter 1.3 times that of Jupiter, but only 1/6 of Jupiter's mass, which makes it a giant, hot, puffy balloon floating in space. The planet's atmosphere is so expanded that it's basically a boiling, raging storm globe, completely unlivable. If you somehow ended up on 127b, survival would be, impossible. The winds would toss you around, the extreme heat would cook you, and the planet itself would offer no solid ground to stand on. You wouldn't be able to breathe, move, or survive even for a second in these extreme conditions. But shockingly, that's not the worst planet you could land on. Imagine a world where it literally rains iron. This is WASP-76b, a planet so close to its star that the day side scorches at over 4,300 degrees Fahrenheit, hot enough to vaporize metals into gas. The night side is cooler, but still a blistering 2,500 degrees. Such a temperature makes those metals condense into clouds and rain down, like molten malted milk balls falling from the sky. The planet orbits its star every 43 hours, and it's tidally locked, which means that one of its sides always faces the star. The winds on the planet are absolutely insane, blowing up to 11,200 miles per hour. They zoom across the planet, fueled by the extreme temperature difference between day and night. And 76b is huge. It's a gas giant twice the size of Jupiter. It's practically sitting on the edge of its star's outer atmosphere. Scientists say we don't fully understand the physics here. Eventually, this planet could spiral into its star, or radiation could strip away its atmosphere, leaving only a scorching rocky core. Now, a human on 76b wouldn't last a fraction of a second. The day side would instantly vaporize you, just like the night side. And don't forget about the winds. You'd be ripped apart before you even touch the ground. And iron rain would slam down around you like fiery pellets. Sounds like a place to avoid. Now, if you're looking for long-term real estate investments, avoid WASP-12b. This planet is over 1,300 light-years away in the Auriga constellation. It orbits its sun-like star extremely closely, completing one orbit in just over one Earth day, about 26 hours. The planet's surface temperature reaches nearly 4,600 degrees Fahrenheit. It is 40% more massive than Jupiter, but powerful tidal forces stretch it into a football shape. But the main problem is that the atmosphere of this planet has expanded to nearly 3 times Jupiter's radius and is being pulled onto the star. And that means the planet is slowly being destroyed. Astronomers think that in about 3 to 10 million years, the planet could be gone for good. They found a huge cloud of stuff flying off the planet, including chemicals never seen on other planets before. No one would survive on 12b. The surface temperature is hotter than molten lava or any furnace on Earth. Any protective suit would fail instantly. The atmosphere is being ripped away by the planet's star, so there's no breathable air, just superheated hydrogen and helium streaming away into space. Plus, the gravity is extreme, so moving there would be, impossible. In any case, you would be vaporized almost instantly before trying to take a step. But however bad this planet sounds, the next world on our list beats it, because it rains glass on this planet. HD 189733b, I'll just nickname it Bubba, is a truly terrifying place, just 64.5 light-years from Earth. It's a gas giant, slightly bigger than Jupiter, and about 11% wider. But don't let that fool you. This world is a nightmare. Winds roar across the planet at up to 5,400 miles per hour, which is about 7 times the speed of sound. Temperatures soar between 1,600 and 2,200 degrees Fahrenheit, hot enough to melt metal. The planet also spins incredibly fast, completing one orbit in just 2.2 days. It races around its star at roughly 341,000 miles per hour. Its cobalt blue color comes not from water, but from a scorching, hazy atmosphere filled with silicate clouds. These clouds can condense into glass, and the planet's hurricane-force winds likely fling it sideways, making the rain fatal. Bubba is a hot Jupiter, a huge gaseous planet racing in a tight orbit around its star. It's also one of the most extreme, hostile worlds astronomers have ever found. If you somehow ended up in this world, survival would be out of the question. The heat alone is lethal. Insane winds would slam you around. An umbrella wouldn't save you from glass raining sideways, which would shred you in seconds. In short, you wouldn't last a heartbeat in this inhospitable world. But there's a planet that makes almost every other world look tame. It's Gliese 436b. It's small for an exoplanet, roughly the size and mass of Neptune, but don't let that fool you. Its proximity to its star turns it into one of the most extreme planets we know. 436b orbits a red dwarf star just 2.5 million miles away. To put that into perspective, Mercury, the closest planet to our Sun, is nearly 36 million miles out. This means that 436b races around its star every 2 days and 15.5 hours. That's lightning fast. A year there is shorter than a long weekend on Earth. The surface temperature is a balming 820 degrees Fahrenheit, which doesn't sound too bad in comparison. But there's the twist. The planet is covered with ice. Now, that's not ordinary ice though. This is Ice 7, a dense, crystalline form of water created under unimaginable pressure. Imagine water so tightly packed that instead of melting under extreme heat, it remains solid. Scientists call it burning ice, and it's a form of ice that Earth laboratories can only replicate under controlled conditions. The atmosphere of the planet is just as bizarre. The planet is mostly hydrogen, like a gas giant, but it contains 7,000 times less methane than expected. Instead, astronomers find a surprising amount of carbon monoxide, which shouldn't survive in such heat. To make it even stranger, 436b is losing its atmosphere. The planet is wrapped in a huge cloud of hydrogen, probably pushed out by the strong gravity from being so close to its star. This cloud is 50 times bigger than the star itself. Unlike a comet's tail, it doesn't get blown away. It follows the planet. Astronomers think that 436b has already lost up to 10% of its atmosphere. Now, if a human, like you, somehow landed on Gliese 436b, survival would be impossible from the first second. The surface temperature is hot enough to vaporize skin and incinerate anything exposed. The gravity is crushing because the planet is dense and packed tightly with matter, which would make a person feel like trying to lift a car with every step. Even worse, can it get worse? Yes. The atmosphere is mostly hydrogen with high levels of carbon monoxide. Breathing would be instantly toxic, and a single inhale would shut down your lungs. And that burning ice is so solid under pressure that even if you somehow avoided the heat and toxic air, the ground itself would be a strange, brittle, crystalline surface that could fracture or collapse underfoot. Add to that the planet's rapid orbit. Completing a full year so fast means winds and atmospheric currents are extreme. No shelter, no suit, and no parachute could protect you. In short, you would be instantly boiled, crushed, and poisoned, all while the strange, dense ice underfoot refuses to melt. Well, bye-bye. In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid called 2024 YR4 had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23rd, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth. Well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there's a very large uncertainty range, about plus or minus 46,000 miles. So it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared. What if Martians came to our planet? What if a Mars rover brought back some unknown organism that began to reproduce and wipe out all life on Earth? Well, we've seen this scenario hundreds of times in movies and read about it in books. But in reality, the situation is the opposite. We are the threat. Humans are the ones that could infect another planet. We are the ones that could become the destroyers of Mars. And to prevent that from happening, countries created an international agreement that forbids us from taking certain actions on our red neighbor in space. It sounds like science fiction, but it's real. This agreement is called the Outer Space Treaty. It was signed in 1967 by the Soviet Union, the United States, and the United Kingdom. The treaty states that no country that signs it can claim sovereignty over any celestial body. It also contains many other important rules, but one of them directly addresses how we should search for extraterrestrial life. Now, there's a possibility that certain regions on Mars could potentially host life. However, According to the Outer Space Treaty, exploring these so-called special regions is prohibited. That sounds strange, doesn't it? Searching for life on Mars is one of the main goals of the entire space industry. So, how can these areas be off-limits? Well, the reason is contamination. When we explore these regions, we might accidentally bring life there. A tiny but extremely resilient microbe or bacterium could hitch a ride on a spacecraft, land on Mars, and begin to reproduce. But scientists are not only afraid that Earth's bacteria will destroy Martian life, there's a possibility that these two types of bacteria will mix, and we will not be able to separate one from the other. But what if it occurs that these bacteria were originally from Earth? Imagine NASA spending billions of dollars collecting samples of Martian soil, where life has been detected. The spacecraft brings these samples back to Earth. Scientists analyze them and suddenly realize that these Martian bacteria are actually ours. They had arrived on Mars 10 years earlier, when a robotic rover was simply taking pictures of the Martian landscape. Here on Earth, we already know bacteria that can survive extreme pressure, incredibly low and high temperatures, and even the complete absence of oxygen. For such organisms, adapting to Mars conditions might not be that difficult. But what if they change in that environment? What if they mutate and take on new forms? Scientists might believe they've discovered true alien life, when in reality, it's just Earth microbes that evolved on Mars. There's also a chance that Martian microorganisms could mix with Earth bacteria, making it impossible to separate them. In short, exploring places where life might exist could create massive scientific confusion. And what if contaminating Mars with Earth's life causes it to spread rapidly? What forms would that life take under conditions completely different from Earth's? Mars and the Moon can be explored, but it must be done with extreme caution to avoid biological pollution. And don't worry, the Outer Space Treaty also requires us to be careful not to bring potentially harmful Martian life back to Earth. So, what exactly are these special regions on Mars? Well, they're places where conditions might allow microorganisms to survive, which are warm and wet spots. But here's the ironic part. We currently don't know locations on Mars that meet these criteria. But if there are such places, we can't reach them. So in practice, this law about special regions hasn't really been tested yet. However, scientists also talk about uncertain regions. These are areas that could potentially be classified as special regions after further study. One example is recurring slope lineae, or RSL. These are dark, narrow streaks that appear seasonally on Martian slopes. At first, scientists believed these streaks were signs of liquid water. Later studies showed that RSL are formed by dry granular flows. So, does that mean there's no chance of finding life on Mars anytime soon? Perhaps. But what about all those headlines claiming that water was found on Mars? Couldn't that mean life exists there? Yes, scientists have discovered water, and it's not just small amounts, but entire oceans. The problem is that this water is buried 7 to 12 miles beneath the Martian surface. For comparison, the deepest hole ever drilled on Earth, the Kola Super Deep Borehole, is about 7.5 miles deep. We couldn't drill deeper on our own planet. Now imagine how much time, money, energy, and technology would be required to make a giant pit on Mars. For now, such a mission sounds more like sci-fi than reality. But let's say we do find a microbe on Mars and bring it back to Earth. What kind of danger could such a tiny organism pose? Well, science fiction thrillers give us dramatic answers, but there's also a real-world example. Take the fungus known as chytrid. This microscopic organism reduced populations of frogs, salamanders, and other amphibians across the globe. And this biological disaster affected humans as well. Chytrid is not an alien organism, but its story perfectly illustrates what can happen after even a small biological contamination. When chytrid infects a frog, it causes a severe disease. The fungus attacks the animal's skin, disrupting its ability to regulate water and electrolytes. Electrolytes are salts and minerals essential for biological functions. When this system breaks, it leads to heart failure. The frog doesn't survive, and the fungus continues to multiply and infect other creatures. The outbreak was first detected in northwestern Costa Rica in the early 1980s. From there, it spread south and east, reaching Panama in the 2000s. More recent research suggests that chytrid originated in East Asia and spread worldwide through the pet trade. How it evolved the ability to devastate amphibians is a story for another video. For now, let's focus on the consequences that still affect us even today. Over several decades, the chytrid epidemic caused massive declines in amphibian populations worldwide. Around 90 species disappeared entirely. The impact was especially severe in Costa Rica and Panama. As amphibian numbers dropped, so did the populations of predators that fed on frogs and salamanders. But that wasn't the main problem. Remember what frogs like to eat. They catch mosquitoes and various bugs. So after the fungus pandemic, the insect population increased dramatically. Now think about what is dangerous about mosquitoes. Yes, they bite and leave an itchy mark on your skin, but some species carry dangerous infections, such as malaria. As frog populations decreased, malaria cases among humans increased. Studies showed that infection rates began rising about a year after amphibian decline started. Over the next 3 years, the number of malaria cases rose, but then stabilized. About 8 years after the chytrid outbreak began, malaria rates started to decline and eventually returned to previous levels. Does that mean frog populations recovered? Unfortunately, no. Amphibians are still struggling. It's possible that humans simply took stronger preventative measures against malaria, or perhaps other animals began feeding on mosquitoes. Either way, the ecosystem never fully returned to its original balance. This is the core problem with biological contamination. Damaging one species disrupts an entire system. Like a chain reaction, problems spread from one link to the next. If a simple fungus managed to affect life on Earth where humans can fight epidemics, imagine what a microbe could do on Mars. Even if life exists there, a single Earth organism could wipe it out completely. The reverse is also true. A Martian microbe could cause serious problems on Earth. Imagine a spacecraft returning from Mars and landing in the ocean. A Martian microbe jumps into the water and attaches itself to a shark. The shark begins to change into something terrifying and starts attacking other sea creatures. Fish become more aggressive and begin attacking anything that moves in the water. Mars's bacteria is multiplying. The fish becomes unsuitable for food. Fishing industry suffers losses, and many people begin to experience hunger without fish. Marine mammals disappear, and things get worse and worse. Okay, let's not be so dramatic, but you get the idea.
You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the moon is only 1/6 as strong as Earth's. that's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the moon, but also how it appeared on Earth. Anyway, what's all that water doing on the moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The moon barely tilts on its axis, only about 1 degree, so the sun never peeks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness, but some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, shadow cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.
So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.